Let's talk about problem 5. We know that there are 100 people waiting for a blood test, and for one person, the probability that the test result is positive equals 0.1. So apparently the probability that the test result is negative equals 0.9. So that's for one person. And as for the method 2, we divide 100 people into 10 groups. So each group have 10 people. There are also two situations. The first one is that all the people is negative, so we don't need to make following tests. And the second situation is that the mixed blood is positive. So we need to test one by one. As for the first situation, the number of the test is 1. Because all people is negative, we don't need other tests. And for the second situation, the number of tests becomes 1 plus 10 equals 11. We set the first situation as event A and the second situation as event B. Then we need to count the possibilities of event A and event B. For each person, the probability that the test result is negative is 0.9. So for 10 people, the probability of all the result is negative is 0.9 to 10th power. So the possibility of event B equals 1 minus possibility of event A. Then we set the number of tests as variable C. Then we can count the expect of variable C. So the expect of variable c equals 1 multiply the possibility of event A plus 11 multiply the possibility of event B. And it equals 1 multiply 0.9 to 10th power plus 11 multiply 1 minus 0.9 to 10th power. So we can get the expect of variable c is 7.513. That's the average number of tests for only one group, and we have 10 groups, so we must use expect of variable c multiply 10. So that is the number of the tests we need to do by the second method on the average.